FEMA tracks 2,900 dryer fires every year. 5 deaths, 100 injuries, 35 million in damage. They blame lint buildup. That's half the story. Electronic control boards and moisture sensors can override a machine's ability to shut itself off. We're counting down 5 failure points the industry does not declassify, and 2 dryers that never had a computer installed. The no electronics loophole. It starts with the component that fails first. In 5th place, the moisture bar sensor sits at the top of the early failure charts. A pair of stainless or nickel-plated bars, wired straight to the electronic control board, is supposed to read the difference between wet and dry laundry by measuring resistance across a thin film of water. In a hard water home, that film leaves a mineral crust. Within 18 months, sometimes less, calcification sets in, and the control logic loses its grip on reality. The numbers are simple. A fresh sensor reads 5 to 30 ohms when wet, and over 2,000 ohms when dry. Calcification drifts the baseline upward by about 1.2 ohms every 10,000 cycles, confirmed in NAL's accelerated fouling study. After 200 loads, the board cannot tell dry from wet. Whirlpool's TSB 00123 and GE's TSB 0845 both warn of this drift, and warranty claims spike right at the 18-month mark. 12% of all dryer sensor failures, most traced to mineral buildup. The outcome splits 2 ways. Sometimes the sensor trips early, shutting down heat with clothes still damp. More dangerous is the silent runaway. The sensor reads wet forever, so the relay keeps feeding current to the heating element. The drum spins, the vent bakes, and a lint pocket goes up after midnight. Mechanical timer dryers never face this chain reaction. Only the electronic failure box can be fooled by a crust of calcium. Service calls for sensor cleaning or replacement run $80 to $100, but the risk curve is steeper. The moisture bar sensor is the first link in the electronics failure chain, the cheapest to fix, but the easiest to overlook. The no electronics loophole means this problem never enters the picture. Stay guarded. In the 4th place, the proprietary firmware board is where the cost curve turns punitive and the fire risk becomes personal. The electronic control board, what I call the electronic failure box, runs the show in almost every modern dryer. Its bill of materials sits at $18, but when it fails, you are looking at a service invoice from $250 to $400 for parts and labor. That is not a repair. That is a forced upgrade. Most boards do not make it past 6 to 8 years. The pattern is clockwork. First, a sensor lies, then the board starts running hot, then the solder joints crack from thermal cycling. Power, MOSFETs overheat, solder pads fatigue, and the board enters thermal runaway. Envista and Quest Integrity both document these failures. Charred PCBs melted traces. Insulation blackened by a runaway relay. In the field, I have seen the aftermath. A control box that should have cut power instead becomes the ignition source, setting lint or insulation on fire. The warranty window is tight, failures spike just after coverage ends, and the economics push most owners straight to replacement. The no electronics loophole is the only way out of this trap. Mechanical timer dryers have no firmware to corrupt, no solder pads to fatigue, no silent ignition source waiting behind a plastic panel. Every extra feature is another entry point for fire. Stay guarded. In 3rd place, the Internet of Things module and Steam system stack is where the complexity tax becomes a fire code violation waiting to happen. The standard dryer used to be a heat relay, a drum, and a timer, nothing else. Now the smart sensor dryer comes loaded with a Wi-Fi module, a cloud-controlled firmware board, a secondary heater for steam, and a water inlet valve that can fail in two directions, stuck open or stuck closed. Every extra chip, every new valve, every remote update is a new path to shut down failure or thermal runaway. UL thermal runaway advisories warn that electronic boards, especially those exposed to moisture from steam cycles, can enter a lockup state, disabling the heat cutoff and leaving the heating element live long after the cycle ends. Service calls for steam valve leaks and Wi-Fi module errors have doubled since 2019, driven by the push for SmartThings, ThinQ, and cloud-linked platforms. When Samsung sunset SmartThings support for dryer models made before 2018, entire cycles went dark overnight. No cloud, no remote shutoff, no error code translation. The hardware still worked, but firmware left the relay logic blind. LG and Whirlpool have both issued support sunset notices, quietly bricking features on models barely 6 years old. Moisture getting into the control board from a failed steam line is a documented ignition source in UL recall files. The complexity tax is not just dollars, it is a risk multiplier. Every new subsystem, every firmware update, every cloud handshake is a new chance for the electronic failure box to outlive its support window and take the house with it. A mechanical timer drive never faces this attack surface. The no electronics loophole is the only way out. Stay guarded. In second place, the Speed Queen TR7 stands alone as the first real consumer escape hatch from the electronic failure box. This is not a smart sensor dryer. There is no circuit board, no digital display, no Wi-Fi handshake waiting to fail. Instead, a cam-driven mechanical timer sits behind the dial, a physical clockwork that rotates a camshaft and opens and closes contacts to control the heat relay and the drum motor. The relay-driven heat cycle starts and ends with a metal click, not a firmware guess. If the timer ever wears out, it's a $40 swap with a screwdriver. If the heating element burns through, the universal nichrome coil costs $35 at any parts counter. No proprietary board, no paired sensor, no cloud update to brick the machine. The entire control stack is relay logic and cam teeth, nothing else. Speed Queen rates the TR7 for over 10,000 cycles, a figure drawn from their laundromat duty spec sheet, not marketing fantasy. The 5-year parts and labor warranty is printed in plain English, covering every mechanical failure except abuse. Every part is standardized and every repair is possible with hand tools. There is no moisture bar sensor to calcify, no board to lock up in thermal runaway, no software to sunset. The only limit is physical wear: cam, relay, motor, element. The same design has run in commercial laundries for decades, where downtime is lost revenue and fire risk is not tolerated. For anyone tired of seeing lint fires started by failed control boards, this is the first real loophole: mechanical, repeatable, and proven. The no electronics loophole is not just a slogan, it is a design fact. Stay guarded. And finally, in first place, the Maytag commercial technology dryer draws the line where every fire risk argument ends. This is the last consumer dryer built for the 20-year run. Direct drive motor, heavy gauge steel drum, and not a single circuit board or sensor in the control stack. The drive system is mechanical from end to end. A centrifugal switch starts the motor, a cam-driven mechanical timer governs the cycle, and a high-limit thermostat cuts the heat if anything runs long. No electronic failure box, no moisture bar sensor, no Wi-Fi handshake waiting to fail in the night. The direct drive motor eliminates the belt, the weak link in every belt-driven unit, so there is no friction heat, no pulley to seize, no rubber to melt and ignite lint. Maytag's own warranty spells it out. 10 years on the drum and motor, parts on the table, U.S. assembly in Marion, Ohio. The manufacturer's reliability claim hovers at 50,000 hours, mean time between failures for the motor, unpublished but consistent with the service records I have seen in the field. The control path is pure relay logic and cam teeth. If the timer wears out, it is a $40 part, not a $400 board. The heating element is standard nichrome, not a proprietary coil. Every repair is possible with hand tools. There are no sensors to calcify, no firmware to sunset, no cloud update to brick the machine. Every feature left out is a fire risk subtracted. This is the definitive buy, the only residential dryer left that closes the no electronics loophole full stop. If you want out of the replacement cycle, this is the last exit. Stay guarded. Across these final two machines, the pattern is blunt. Every electronic failure box adds risk. Every mechanical timer drive subtracts it. The no electronics loophole is not nostalgia. It is the only proven firewall left. In dryers, every added feature is a future ignition point. Stay guarded.